Welcome back, students. So in today's problem we are going to start the exercise problems, and from the exercise problems we have picked a problem which is of 4.63, and there are many sub problems in it, and in first of its part it asks us to find the value of the voltage V naught by using the source transformation method. Okay, so let us start it from here. So first of all, when we will start transforming this circuit by using the source transformation method, so we can easily see here that there are two resistors. One is this one, which is in series with the current source, and the other one is here, this one, which is in parallel with the voltage source. So in order to transform it by using the source transformation method, we have to remove these sources here. So when we will remove it, what I will get here, I will get a transformed version of this circuit like, okay, so when it will be removed, the parallel is this voltage source, so it will be replaced here. Similarly, this one, and this is the circuit. Okay, so this is of 520 volts, this is the 4 ohm resistor, 6 ohm, again here 40 ohm, the current source here. Okay, so now this is the circuit, and the circuit here, this is the 250 ohm resistor across which we have to find the voltage V naught. Okay, so now this is the first transform circuit, and we have to again transform it in order to find the voltage V naught here. Okay, so here we can clearly see that when I will use the red color, I can clearly see here that this is the current source, and along with we have a resistor which is in parallel with this current source. So we can easily transform this circuit into our transformed version. So in order to transform it, it will be converted into a voltage source and a resistor which is here. Okay, so this is the transformed version, and in transformed version it will be positive, it will be negative. What will be the value of the resistor which will be in parallel with the transformed voltage source? That would be the same as it is here in parallel with the current source. And what will be the value of the voltage source here? It can be calculated by using the Ohm's law formula, V is equal to IR. So putting the value of I, which is 1, and R is 40, so I will get here 40 volts, so it will be 40 volts. Okay, so now this is my circuit, and the remaining circuit which was not transformed yet is here a voltage source plus minus a resistor here and a similar resistor here. Okay, this is a 4 ohm, this is the 6 ohm, and the 250 ohm resistor. Okay, we have to find out the voltage across this one. So now as we have two voltage sources, first is this one and the second one is here. So in order to find the cumulative voltage here, we have to combine them because as we can see here that the resistors 40 ohm, 4 ohm, 250 and 6, these are in series with the two voltage sources which are 520 volts and 40 volts. So what we will do, we will basically combine our voltage sources. Okay, so this is my first voltage source, this is the second voltage source, you can see here, and the first resistor here is this 40, the second one is here 4, the resistor which is connected here is the 6 ohm, and this is the 250 ohm resistor. Okay, so now we can see that these 4 resistors are in series with each other, so we can add this and this resistor together. Similarly, while combining the voltage sources, we can see we can observe the polarity of this 520 volts voltage source, which is like this one, and similarly the polarity of this voltage source is this one. So we can see here that we can very easily see here that as the polarity of these two voltage sources are in opposite direction, so in combining them we can easily combine them like, as the polarity is opposite, so polarity the voltage of the one source will be subtracted from the other one. So let us subtract this lower voltage from the higher one. Okay, so it will be 480 volts. Okay, so and what will be the polarity or the cumulative polarity of this voltage source? The sign of the this voltage source will be as that of the dominant voltage source here. Okay, so we can see here that the 520 volts is the dominant voltage source among these two, so therefore the polarity of 480 will be the polarity of the dominant source here. Okay, so it is now plus negative, positive and negative here. So now adding them 44 and 6, we will get here 50 ohm, and similarly 250 ohm resistor here. Okay, so now this is the voltage. So now in order to find the V naught, we can easily see here that the value of 250 ohm is basically our V naught. Okay, so that is the V naught, and we can easily find out by using many methods, but let me use the voltage divider rule here. So by using the voltage divider rule here in this series circuit, what I will get, 250 divided by 250 plus 50, that would be 300 multiplied by 480. Okay, so when I will do it, what I will get here 400 volts. So that is the value of V naught, and that is the answer of part A of this question. Okay, so that's it, and this is the answer of part A here. So now let me proceed and see what is it asking us to find more. So in part B of this question, what is it asking us is to find the power which is developed by this 520 volt source. So in order to find the power delivered by this source, we can easily see here that, let me change the color here. So let me use this color here. So I can easily see here that the value of this V naught, as I have found out, is the 400 volts. Okay, so that is the voltage here. Similarly, the voltage which is developed across this one is the 520 volts. Okay, so now in order to find the value of the current here, let me call it I prime. Okay, so in order to find the power delivered by 520, what should I have? I should have the current which is flowing through this 520 volts 520 volt multiplied by the voltage of 520 volts source. So as we know the value of the voltage here, so just we have to find out the value of the current here. Okay, so now the value of what will be the value of, what is the value of I prime? So the value of I prime, we can easily see here that there are basically as I clearly shown you guys, that with every single element we have three quantities which are associated. What are those quantities? The first quantity is the current which is flowing through that element. The second one is the voltage which has been developed across that one, and the third one is the resistance or the impedance. If any two of these three quantities is known, we can easily find out the third quantity. Okay, so as the voltage across this 250 ohm is known, so we can easily find out the value of current by using the Ohm's law. So what it would be, it would be 400 divided by 250, and the value of it will be 1.6 amps. Okay, so that is the same current which is flowing through all of these resistors. Okay, the same current which is again here. So as this current is flowing through this one, so we can easily see here that the source here is providing us the I naught. This I naught is divided into two currents. The first one is I prime and the second one is this I double prime. Okay, so now here what is the value of I double prime? The value of I double prime is basically the voltage across 260 ohm resistor divided by the resistance of the 260 ohm, which is known. So this is the current which is flowing here. So let me write it here again. Let me use this blue color. So we can see here that this is our circuit. Okay, so now this is my 520 volts source across which I have to find out the power dissipation. Okay, I have to find it out. So now in order to find the power, I should have the current value, I should have the voltage value. As the value of the voltage is already known, I have to find out the value of this current. Okay, I should have the value of this current, and I am calling this current as I naught. When it will reach at this node, it will be divided into two currents. The first current here is I prime and the second current here is I double prime. Okay, this I double prime is flowing through the resistor which is in parallel with this source. Okay, so in order to find the value of, sorry, this is the source. So in order to find the value of I double prime, what I have to do, again I should have the value of the voltage across it and the value of the resistance, which are known. So what is the value of the voltage across it? That is the 520, because this 520 volt source is in parallel with this resistor, and similarly it is 260. So finding it out, I will get here 2 amps. Okay, so now what is the value of the, sorry, this is part B. So what is the value of I naught which is flowing through 520? That is basically I prime plus I double prime. Do I know the value of I prime? Yes, that is already calculated, and the value of it is 1.6. and similarly the value of I double prime is also calculated, and that is 2 amps. Okay, so adding them I will get 3.6 amperes. Okay, so now in order to find the power provided by this 520 volt source is the I naught into 520 volts, and the value of I naught is already known, that is 3.6 multiplied by 520, and calculating it, what I will get, let me calculate it by using the calculator. So 3.6 multiplied by 520, I will get 1872 watts. Okay, so that is the power which is provided by 520 volts resistor. So that is the solution and answer of the question. So let me remove it and write it clearly here. So that is now 1872 watts. Okay, so now that is the answer of this part B. So now in order to find the other quantities, let me now remove all these. So okay, so So I have drawn it down. So now in order to okay, so now in order to find the other quantities and the solution of find the power which is developed by the 1 ampere source. So in order to find the power which is developed by this 1 ampere source, what I should have the current I1 multiplied by the voltage which has been developed across this one. So I should have this voltage, or let me write precisely, because the polarity is in opposite. So I have to find out this V1 here. In order to find out this V1 here, I should have in this loop this voltage V16 and this V40. Okay, so according to the KVL, the value of, if I apply KVL here, what it will become, it will be V1 is equal to the V16 plus V40. okay, so it will be like this one, but we don't know, let me call it equation number 1, but we don't have the value of V40. So in order to find the value of V40, what should I have? I should have the values of the voltage which has been developed across 260 plus 4 ohm resistor plus 250 resistor, 250 ohm, and similarly the 6 ohm V6. okay, this will be the value which will be equal to this V40, and as the summation of it will be equal to 0. Sorry, I have just written it equal, but it is not equal to this one, because all of these are basically the resistors, so therefore it will be equal to 0. So in order to find the value of V40, what I will have, it will be minus V260 plus V4 plus V250 plus V6. okay, so do I know the value of V250? Yes, I know the value of 250, which is 400. Do I know the value of V4? No, we don't know, but the current across it is already known, and that is 1.6. Similarly, the same current is flowing through this one, that is 1.6, and the value of this is already known. So let me write these values, but here we can easily see that this is the voltage which has been raised by, and the polarity of this would be like this one. So the polarity of it all is just depending upon this 260, so it will be here, sorry, it will not be like this one, so it will be V40 equal to minus, what is the value of 260, that is 520 plus V4 plus V6, that is 1.6 multiplied by the 4 plus 6 and plus 400. These values all already known, so adding them, what I will get, minus 520 plus 400 is 920 plus 1.6 multiplied by 10 is 60. So the value of V40 will be equal to the 936 volt, minus 936 volt, and that is the value of V40. okay, so now in order to find, calling it 2 and putting 2 in 1, okay, putting 2 in 1, what I will get, here V1 is equal to the V16 plus the value here is V40, and that is minus 936 but again we don't know the value of V16, but the same current in this loop is flowing, which is of 1 ampere. So multiplying this current with the resistance here, I will get V1 equal to the 16 multiplied by 1 minus 936. So here V1 will be equal to the 16 minus 936 will be equal to minus 920 volts. So that is the value of V1. Let me call it equation 3, and putting it in this equations, which was equation number A. So now when I will put it, what I will get, the value of I1 is basically 1 and the value of V1 is minus 920. Okay, so putting it here, what I will get, the value here will be minus 920 watts. Okay, so that is the answer of part C of this question. Okay, so that is the end of part 3. In order to verify the total power developed equals the total power which is dissipated, we have already found out all the values which are let me move it down. So we have already found out all the generated powers by the sources. So now in order to verify the all the powers which are dissipated are equal to the powers which are generated by the sources, we have to see that the power generated by P1 source plus P520 is equal to the powers which are dissipated across the 16 ohm resistor plus, sorry, let me remove it, it is not the correct way, as I am already adding them. So this would be equal to P16 plus P40. I am starting it from here and then going here, plus P260 plus P4 ohm plus P250 ohm plus power across 6 ohm. Okay, so this is the equation, let me call it equation B. As we know all the values related to each of the element here, so we can easily verify that the power which is developed across the sources is equal to the powers which are dissipated across these sources. Okay, as I know the value of the voltage across V40 ohm resistor, similarly the current across this one, the voltage across 260, and all the currents across 250, 4 and 6. So I can easily use the power dissipation formula, which is the V square divided by R or I square R, to find out the power dissipation here. So after finding out all the power dissipations, I can put these here and verify that the summation of the summation of all the powers developed will be equal to the summations of R powers dissipated. Okay, so it will be the answer of my part D. So that's the end of 4.63 exercise problem, and we have seen all the rudimentary steps which are essential in solving these type of circuits, in which you have to find out other quantities after transforming a circuit by using the source transformation method. So I think it's enough for your conceptual overview of such kind of problems. That's it, and I will see you in the next video. Till then, take care of yourself and thank you so much.